Phoenix Fly is a brand that specializes in designing and manufacturing wingsuits for skydivers and base jumpers. Their suits are engineered to allow individuals to glide through the air for extended periods after jumping from aircraft or fixed objects like cliffs or buildings. These wingsuits have a unique design with fabric panels between the legs and under the arms, creating an airfoil shape. This shape generates lift, much like the wings of an airplane, enabling the wearer to control their descent and move horizontally across the sky. The idea behind Phoenix Fly's wingsuits is to give skydivers and base jumpers an experience closer to human flight. By spreading their arms and legs while wearing the wingsuit, individuals can catch the air, creating aerodynamic lift. This lift allows them to soar for several minutes, covering substantial horizontal distances before deploying their parachutes for a safe landing. Safety is a paramount concern in wingsuit flying, and Phoenix Fly designs their suits with safety features and considerations. They work on improving the aerodynamics, stability, and durability of their suits to enhance performance while prioritizing the safety of the wearer. Wingsuit flying requires significant skill, training, and experience. Jumpers need to undergo rigorous training to understand the aerodynamics of the suit, practice flying techniques, and learn how to navigate safely through the air before attempting more advanced maneuvers or longer flights. Phoenix Fly, like other wingsuit manufacturers, constantly innovates and refines their designs, incorporating feedback from experienced wingsuit flyers and utilizing advancements in materials and aerodynamics to improve the performance and safety of their suits. Overall, Phoenix Fly's wingsuits have revolutionized the world of skydiving and base jumping, allowing enthusiasts to experience the thrill of flight in a way that was once unimaginable, albeit with a strong emphasis on safety and skill development. The Zapata Flyboard Air is a groundbreaking personal aerial vehicle developed by Frankie Zapata and his company, Zapata Industries. It gained significant attention for its ability to hover and fly, offering a unique experience of personal flight. The Flyboard Air is essentially a hoverboard-style platform powered by jet engines, allowing an individual to fly untethered through the air. Unlike traditional jetpacks or hoverboards, which rely on water propulsion or limited flight capabilities, the Flyboard Air is a self-contained flying platform capable of achieving impressive altitudes and speeds. At its core, the Flyboard Air utilizes turbine engines fueled by kerosene to generate thrust. These engines provide the necessary power to lift the rider off the ground and maintain stable flight. The platform includes stabilization systems and onboard computers to assist with balance and control during flight. The design of the Flyboard Air includes multiple jet engines, usually positioned beneath the platform, providing vertical lift and maneuverability. The rider stands atop the board, using their body movements to control direction, altitude, and speed. One of the most notable features of the Flyboard Air is its ability to achieve impressive flight capabilities, reportedly reaching altitudes of over 10,000 feet and speeds exceeding 90 miles per hour. These capabilities offer a sense of freedom and exhilaration akin to personal flight. However, flying the Flyboard Air requires significant skill, training, and expertise due to the complexities involved in maneuvering a jet-powered platform. Controlling the device demands a good understanding of balance, weight distribution, and responsiveness to subtle body movements. Safety has been a critical concern surrounding the Flyboard Air and similar personal aerial vehicles due to the inherent risks associated with flying at high speeds and altitudes. Zapata Industries has emphasized safety protocols, including comprehensive training for pilots and implementing safety features within the platform itself. Despite its impressive capabilities, the Flyboard Air remains a specialized and experimental technology, with limited commercial availability and strict regulations governing its use in many regions. Frankie Zapata's innovation with the Flyboard Air has showcased the potential for personal flight and pushed the boundaries of what's possible in the realm of aerial transportation, sparking both excitement and discussions about the future of personal aviation. The Gravity Jet Suit is an innovative and attention-grabbing personal flight system created by Gravity Industries, founded by Richard Browning. It's a pioneering jet-powered exoskeleton that allows a user to achieve human flight by using multiple jet engines mounted on various parts of the body. These engines are strategically positioned on the suit, typically including engines on each arm and sometimes on the back or legs. These engines provide the thrust needed for vertical takeoff and controlled flight. The suit runs on aviation-grade kerosene or diesel fuel, which powers the jet engines. The fuel is stored in small tanks on the suit, providing enough propulsion for several minutes of flight. Pilots control the suit's direction, altitude, and speed by adjusting their body position and the throttle controls integrated into the suit's design. Stabilization is achieved through gyroscopic and inertial sensing technology. The gravity jet suit allows the wearer to achieve a variety of flight maneuvers. The suit enables the user to lift off vertically from the ground and land in a similar manner, offering flexibility in accessing different terrains. By adjusting the thrust from the engines and their body position, the wearer can move forward, backward, or laterally, providing a degree of controlled flight. The suit allows for agile and dynamic movements, such as turning, banking, and ascending/descending, offering a sense of freedom and maneuverability in the air. Gravity Industries continually refines the jet suit's design and functionality, focusing on enhancing safety measures and flight control systems. Pilots undergo extensive training to operate the suit safely and effectively. Safety remains a top priority, and the team continuously evaluates and improves upon the suit's safety features, flight dynamics, and pilot training protocols. The gravity jet suit has garnered attention for its potential applications beyond entertainment and demonstrations. The suit's mobility could potentially aid in reaching remote or inaccessible areas quickly, assisting in search and rescue operations. There might be applications for military and defense purposes, such as rapid response or reconnaissance in certain scenarios. Although in its early stages, there's speculation about potential commercial uses, such as aerial logistics or specialized transportation in specific industries. While the gravity jet suit represents an incredible leap in personal flight technology, there are challenges to address. Integrating such technology into civilian airspace requires navigating complex aviation regulations and safety standards. Currently, the technology remains costly and inaccessible for widespread use due to its experimental nature and specialized design. In summary, the gravity jet suit stands as an awe-inspiring example of human ingenuity, showcasing the potential for personal flight technology. Its development continues to inspire imagination and innovation in the realm of aviation and human mobility, although practical applications beyond entertainment and demonstration are still being explored and refined. Zero-G parabolic flights are unique aerial experiences that simulate weightlessness by flying an aircraft in a parabolic trajectory. These flights offer passengers the sensation of floating as if they were in space. The aircraft follows a flight path that consists of a series of parabolas, which are arcs that simulate different gravitational conditions. As the aircraft climbs sharply and then descends at a steep angle, passengers inside experience periods of weightlessness lasting about 20 to 30 seconds each. During the ascent, the plane maneuvers at an angle that creates a period of increased gravitational force, providing a feeling similar to being on the moon. Then, as it descends rapidly, the plane enters a freefall state, causing the passengers and everything inside the aircraft to experience apparent weightlessness or microgravity. These flights are used for scientific research, astronaut training, and entertainment purposes. Researchers conduct experiments in this microgravity environment to study the effects of weightlessness on the human body and various materials. Astronauts also use these flights to prepare for the sensations they'll experience in space. Additionally, some companies offer these flights as unique experiences for thrill seekers who want to float freely in the air for short periods. Overall, zero-G parabolic flights offer a brief but exhilarating experience of simulated weightlessness, allowing passengers to float, flip, and experience a sensation akin to being in space for a short period before returning to normal gravity. The Atmosphere is a thrilling amusement park ride that belongs to the category of freefall towers. It's designed to provide an exhilarating experience by lifting riders to a significant height before releasing them in a controlled freefall descent. The Atmosphere typically consists of a tall tower structure with a platform or cabin that can carry riders. The height of these towers can vary but often ranges from around 200 to 400 feet. Riders are seated or standing inside the cabin, which ascends vertically up the tower through mechanical means such as a motorized pulley system or hydraulic lift. The ascent provides a gradual buildup of anticipation as the cabin climbs to the top. Once at the peak height, the cabin is briefly held in place before being released or dropped, allowing gravity to pull it downward. Riders experience an exhilarating freefall, feeling the sensation of weightlessness and speed as they plummet toward the ground. The Atmosphere provides a rush of adrenaline as riders experience the feeling of free-falling from a considerable height in a controlled environment. Riders often enjoy stunning views from the top of the tower before the drop, adding to the excitement and anticipation of the thrilling descent. Riders are secured with appropriate safety harnesses or restraints to ensure their safety during the ascent, freefall, and deceleration phases. The drop is carefully controlled and regulated by braking or deceleration systems, ensuring a smooth and safe landing. The Atmosphere, along with similar freefall towers, attracts thrill seekers and those seeking an adrenaline-pumping amusement park experience. It's a popular attraction in amusement parks worldwide, offering an intense but controlled thrill ride that appeals to a broad range of visitors seeking excitement. In essence, the Atmosphere Freefall Tower delivers an intense and controlled freefall experience, providing riders with an adrenaline rush and a thrilling sensation of weightlessness as they plunge from a towering height before safely coming to a stop at the bottom. Commercial space flights, also known as space tourism, involve private companies offering individuals the opportunity to travel to space for recreational or experiential purposes. These ventures represent a significant shift from government-led space exploration to opening space travel to private citizens. The concept of space tourism gained traction in the early 2000s. Denis Tito became the first private individual to travel to space in 2001 aboard a Russian Soyuz spacecraft, paying for the trip to the International Space Station (ISS). Companies like Virgin Galactic and Blue Origin are pioneers in offering suborbital spaceflights. Suborbital flights typically reach the edge of space, providing passengers with a few minutes of weightlessness and a view of Earth from space. Virgin Galactic aims to provide suborbital spaceflights aboard their Spaceship Two spacecraft. Spaceship Two is launched from a carrier aircraft, then ignites its rocket engine to propel it to the edge of space. Passengers experience several minutes of weightlessness and get a glimpse of the curvature of Earth from space before returning. Blue Origin's New Shepard spacecraft offers suborbital flights for space tourists. The New Shepard rocket vertically launches and lands, with a crew capsule that detaches for a few minutes of weightlessness. Passengers experience a brief period of weightlessness and witness Earth's curvature from the capsule's large windows. SpaceX, led by Elon Musk, has plans for civilian space travel, aiming for orbital missions. SpaceX's Crew Dragon spacecraft has already taken NASA astronauts to the ISS. The company intends to offer private missions, potentially orbiting Earth for a few days. Space tourism is currently reserved for the ultra-wealthy due to its high cost, with tickets ranging from hundreds of thousands to millions of dollars. Passengers undergo varying levels of training, from safety briefings to experiencing G-forces, to prepare for the journey. Companies prioritize safety, subjecting their spacecraft to rigorous testing and ensuring redundancy in critical systems. Some discussions focus on the environmental impact of space tourism, considering its carbon footprint and sustainability. Advances in technology and increased competition might eventually lead to reduced costs, potentially making space travel more accessible to a broader demographic. As technology evolves and becomes more reliable, companies might expand offerings beyond suborbital flights, possibly venturing into longer orbital missions or trips to destinations like space hotels. Space tourism has the potential to inspire future generations and stimulate interest in space exploration, science, and technology. Discussions center around the equity of allocating resources for space tourism while pressing issues on Earth remain unresolved. In summary, commercial space flights represent a groundbreaking shift in space exploration, opening the cosmos to private individuals willing to embark on journeys beyond Earth's atmosphere. While currently a luxury experience, continued advancements and evolving technologies may pave the way for a more accessible and diverse space travel industry in the future. Zoarbi Rotorua is an adventure activity based in Rotorua, New Zealand, offering a unique and thrilling experience known as zorbing. The concept involves rolling downhill inside a giant inflatable ball, providing participants with an exciting and adrenaline-pumping adventure. Participants enter a large, transparent inflatable ball known as the Zoarbi. These balls have multiple layers, with an inner chamber providing cushioning and safety for the riders. The Zoarbi is then rolled down a specifically designed track or slope. The track can vary in design, featuring twists, turns, and different gradients to enhance the rolling experience. Riders can experience the ride with water inside the ball, adding an element of slipping and sliding. Participants are strapped into a harness inside the ball, allowing them to be flung around as the ball rolls downhill. Riding inside the Zoarbi provides a unique sensation of rolling and tumbling down a hill, offering an adrenaline rush and a sense of weightlessness as the ball moves. It's a highly entertaining activity, often attracting thrill seekers and those looking for a unique adventure experience. Zoarbi Rotorua ensures safety by having trained staff, secure harnesses, in certain rides, and maintaining strict operational standards. The Zoarbi concept was invented by Andrew Akers and Dwayne van der Sluis in New Zealand in the 1990s. Zoarbi has gained international recognition, with locations in various countries offering similar experiences. Zoarbi Rotorua has become a popular tourist destination, drawing visitors from around the world seeking an exhilarating and memorable experience. The success of Zoarbi Rotorua has contributed to the local economy by attracting tourists and creating employment opportunities. Zoarbi Rotorua stands as an innovative adventure activity, allowing participants to roll downhill inside a giant inflatable ball, providing an exhilarating and entertaining experience. It's a thrilling attraction that has gained popularity both locally and globally, offering a unique adventure for those seeking a memorable and adrenaline-fueled activity during their travels. Flying inflatable boats (FIBs) are innovative watercraft that combine the features of a traditional inflatable boat with the ability to fly above the water's surface. They offer a unique and exhilarating experience by utilizing a combination of powerful propulsion and aerodynamic design. FIBs are primarily made of durable and lightweight materials like PVC or Hypalon, providing buoyancy and flexibility. The inflatable tubes around the hull provide stability and help the boat stay afloat. FIBs incorporate wings or hydrofoils that extend beneath the water's surface. These structures, similar to those found on hydrofoil boats or planes, generate lift as the boat gains speed, allowing it to rise above the water. Typically, FIBs are equipped with powerful engines, often high-performance outboard motors or jet propulsion systems, providing the necessary thrust to achieve planing and lift. Similar to regular inflatable boats, FIBs initially operate as conventional watercraft, skimming the water's surface while being powered by the engine. They move at higher speeds, utilizing their inflatable hulls to plane on the water. As speed increases, the wings or foils beneath the surface generate lift, gradually elevating the boat above the water. The transition from waterborne to airborne mode occurs as the foils or wings counteract water resistance, allowing the boat to fly above the surface. Once airborne, the FIB glides smoothly over the water's surface, offering a sensation akin to flying. Riders experience reduced drag and increased speed as the boat lifts clear of the water. Flying inflatable boats provide an exhilarating experience, combining the speed of a powerboat with the thrill of flying above the water. FIBs are versatile and can be used for various purposes, including recreational activities, water sports, coastal patrols, rescue operations, and military applications. Operating FIBs requires skill and training due to their unique handling characteristics, especially during the transition from water to flight mode. Safety considerations are crucial, including proper training, adherence to weight and speed limits, and ensuring the integrity of the inflatable structure. Flying inflatable boats represent an exciting fusion of inflatable boat technology with flight principles, offering an adrenaline-pumping and versatile watercraft experience. With their ability to glide above the water's surface, they provide an exhilarating adventure for enthusiasts while showcasing innovative engineering and design in the realm of water-based transportation.